In this video, we will be solving a radical equation that simplifies to a linear equation. This is going to be with one radical, so one square root on these problems. And we're going to do some basic ones, and then we'll do some ones that are just a little bit more advanced. Okay, so let's start with the basic ones. We have the square root of w minus 6 is equal to 5. Okay, oh, and one other thing, recall, we're sticking with real numbers. Just like the last video, we're sticking with real numbers. So if you have a square root equal to a negative number, you can stop the problem right there and say no solution. Okay, so circle with a line through it, no solution. Okay, so square root of w minus 6 is equal to 5. We're going to solve these just like we did in the last video, and if you didn't see that, you need to. It's called Introduction to Radical Equations. Okay, so we will square both sides just like we did before, and everything on the inside is included in that. So when we square this, the whole square root goes away and the w minus 6 is what stays. But since it's an equation, we have to square the other side as well. So I'll be raising both sides to the 2 power. So the square root and the square cancel, that's w minus 6. We square the other side, that's equal to 25. Okay. And then we will solve for w by adding that 6 to the other side. Okay, and then that will give us w is equal to 31. Now, we should check our answer on this because occasionally when you start dealing with square roots or radical equations, they can give you answers that aren't actually answers. So we're going to just plug these in and make sure. So I'll plug the 31 in there. What I want to do is see if this is true. So if the square root of 31 minus 6, that's what we found, replacing it with w, the square root of 31 minus 6 equal 5. Let's find out. 31 minus 6 is 25. And the square root of 5, or 25 is 5. So that one checks out and we're good. Okay, so our answer is w is equal to 31. Okay, let's look at this one. So in this one, we need to move something first. We can't just square because the square root has to be by itself. So there's this 3 that needs to be moved. The 11 can stay put because it's underneath the square root. Okay, but this 3 is over here, and we can't square this square root unless it's by itself. So I need to first subtract a 3 from both sides to get it to the other side. Okay, and that would be square root of u plus 11, and 2 minus 3 is equal to negative 1. Okay, let's recall our rule up here. Rule number 1, after we isolate the radical, the square root of anything is equal to a negative number, no solution. So when we get to this point where it's a square root on one side and a negative number on the other, we can stop and we can say that's no solution there. Okay, let's look at another one. So in this one, the thing that's inside the square root is v plus 2. We need to get this whole square root by itself, which means we need to get rid of this negative 2. So I can add 2 to get rid of it. It's the opposite, right? So add 2 to both sides. And that will give me the negative 2 will go away. I have the square root of v plus 2 is equal to 9. Okay, so this one is solvable because unlike the last one, this is a positive number over here. So now I can square both sides. Okay, and remember when you square a square root, the inside is what stays. So v plus 2 equals 9 times 9, or 9 squared is 81. And we subtract 2 from both sides to get v by itself. So that will be v is equal to 79. Now, since we came up with an actual solution on this, let's go ahead and plug it in and see if it works into the original equation here. So that's negative 2 plus the square root. Instead of v, we'll write 79 plus 2 equals 7. Let's see if this is actually true. So 79 plus 2 is 81. So negative 2 plus the square root of 81 equals 7. The square root of 81 is 9. So negative 2 plus 9 equals 7. Is this true? Well, if we do 9 minus 2, that is 7. So 7 equals 7. So that checks out, which means our solution is this right here. Okay. Let's do a few more of these. Okay, so these are going to have some other numbers on the inside here, like we have this 6y here instead of just a variable. But the process is the same. We're still going to square both sides. Okay, so once I square both sides, the inside stays at 6y minus 5 is equal to 7 squared, which is 49. And then I will add this because I'm trying to get the y by itself, right? So I need to get rid of all the numbers that are over there with it. So I add that 5 to get rid of it. That becomes 6y. And then 49 plus 5 is 54. Okay, and then to get rid of the 6 that's multiplied by the y, I divide. Okay, and that will give me y is equal to 54 divided by 6 is 9. Okay, let's see if that solution works before we say it's good. So we plug it in. Instead of 6y minus 5 in the square root, I'm going to do 6. We know y now is 9 minus 5, and then equals 7. Let's see if that's true. 6 times 9 is 54. So the square root of 54 minus 5 equals 7. 54 minus 5 is 49. So does the square root of 49 equal 7? Yes. So this solution checks out for us. Okay, let's look at this next one. So we've got all this stuff here. In the square root, we've got this plus 4 that's over here, which can't be. We need to move it. So that's the first step we do, is get rid of that 4. Move it to the other side by subtraction. So that will give us square root of 3u minus 14 is equal to 2 minus 4. That's negative 2. So what does that mean? Since we have a square root that's equal to a negative number, no solution. Okay? And then one last problem. So we've got square root of 4x minus 31 plus 6 equals 5. I need to isolate the square root, so I get rid of this by subtraction. So that would give me the square root of 4x minus 31 equals negative 1. And that means no solution. And that's it.